In today's lesson, we'll be learning about SOH CAH TOA, also known as the primary trigonometric ratios. In a previous lesson, we learned that SOH CAH TOA is a mnemonic which helps us remember the primary trigonometric ratios. The SOH in SO helps us remember this ratio, while the CAH in CA helps us remember this ratio, and the TOA in TOA helps us remember this ratio. This tool should look familiar to you. This is a protractor. A protractor measures angles in degrees. These two lines would make a 90-degree angle, while these two lines make a 30-degree angle. This angle is an acute angle. Acute angles are less than 90 degrees. These two lines would make a 150-degree angle. This is an obtuse angle. Obtuse angles are greater than 90 degrees. In our first example, we have a right triangle. We want to find this unknown called theta. In other words, we want to find the angle between these two lines. Before doing any calculations, let's make an estimate. Is this a 90-degree angle? Is this an acute angle? Or is this an obtuse angle? This definitely is an acute angle, which means it must be less than 90 degrees. I'm going to estimate that it is about 45 degrees. Since we are positioned at theta, this side would be the hypotenuse since it is the longest side. This side would be the opposite side since it is located across from us. This side would be the adjacent side since it is located beside us. Since we're trying to find this unknown angle, we're going to need the help of some information. We know the hypotenuse is 15 centimeters long, and we know the adjacent side is 11 centimeters long. Therefore, I'm going to circle those two sides since those would be useful for us to find an unknown. I'm not going to circle the opposite side since we don't have any information for it, and that is not going to be useful for us when finding an unknown. At this point, take a look at the three trigonometric ratios. Which ratio contains both the hypotenuse and the adjacent? You'll find that this ratio contains both adjacent and hypotenuse, and that is the ratio that we'll be using to find this unknown angle. I want you to take a close look at this ratio. We don't know what theta is, therefore that is going to stay the same. I'm going to replace adjacent with the number 11. I'm going to replace hypotenuse with the number 15. I can't really do anything with cos theta right now, so that is going to stay the same. But what about 11 over 15? That is the same thing as 11 divided by 15. I want you to put that into your calculator. You'll get a long decimal, but I'm going to round this to 0.733. Something doesn't look right. I estimated our unknown angle to be about 45 degrees, but I'm getting something extremely small. To change this number into something more reasonable, we're going to have to use a new button on our calculator. It's going to look like this. It's going to say cos with a -1 beside it. A scientific calculator will have this button, but with a phone, you'll likely have to turn your phone sideways. To access this button, you're either going to have to press the second button, the inverse button, or the shift button before finding this one. Now, depending on your calculator, you may have to press this button first, then enter this number, or enter this number first, then press this button. Once you do that, you'll get approximately 42.9 degrees. Before doing any calculations, we estimated this unknown angle to be about 45 degrees since it looked like an acute angle. And after doing our calculations, we got something very similar. So theta is actually equal to 42.9 degrees.